Section 11.2 continued, surface area of prisms and cylinders. The definition of a cylinder is a figure that has two congruent parallel bases, and those bases are circles. Here we have a diagram of a cylinder. Notice the base on top is a circle, the base on the bottom is a circle, and they are parallel. I have an altitude, which is a perpendicular segment that joins the two bases. Here, I have a segment that is perpendicular to both bases, and the representation of our length is that altitude. The orientation of our cylinder does not matter by the definition of the parts of the cylinder. Here I have a cylinder on its side, and the bases are still the circles of the cylinder, the two parallel circles. The altitude is still the segment that is perpendicular to both circles, still represented by the height. As in our previous section, we know that prisms are either right prisms or oblique prisms. Similar to that, we have a right cylinder or an oblique cylinder. The right cylinder has a lateral edge that is perpendicular to the two bases. An oblique cylinder is a cylinder that is skewed in such a way that the lateral edge is not perpendicular to the two bases. Here, the altitude is on the exterior of our cylinder. Theorem 11.2, lateral and surface areas of a cylinder. The lateral area of a right cylinder is the product of the circumference of the base and the height of the cylinder. Let's recall that if I have a circle, I have a radius, which is a segment from the center of the circle to a point on the circle. And I have a diameter that is a segment that goes through the center and also intersects 2 points on the circle. That is the diameter. And also recall that the diameter is equal to 2r. 2 radii equals a diameter. Also recall that the circumference is the distance around our circle, and the circumference is equal to 2 pi r, or pi times d. In this instance, I have the diameter equal to 2r. Therefore, the lateral area is equal to 2 pi rh, where 2 pi r is the circumference. Or I have the lateral area equal to pi times d, where pi times d is the circumference. The surface area of a right cylinder is the sum of the lateral area and the areas of the two bases. The surface area is equal to the lateral area plus 2 times the base areas. Or also, the surface area is equal to 2 pi rh here, the circumference times the height, which is our lateral area, plus pi r squared, the area of a circle, is equal to pi r squared, and I multiply that by 2 because I have two bases, which are two circles. In this example, they want us to find the lateral area of the cylinder in terms of pi, and then round the answer to the nearest whole number. Here we're given a cylinder, and my two circles I know are the bases, and it has a radius of 5 inches. The altitude, which is the height, is 12 inches. The green surface represented in my cylinder is the lateral face. Here I have a partial net of that lateral face, which is represented with a rectangle. I know the length of my rectangle is going to be the circumference of the circle, which is 2 pi r, or pi times d, and the height I know is going to be 12. I know the formula for lateral area equals 2 pi r h. And when I substitute, I get 2 pi r, I know is 5, and I know the height is 12. And when I simplify that, I'm going to get 2 times 5 is 10. 10 times 12 is 120 pi. And that answer is in terms of pi. This is 120 pi square inches. And this is in terms of pi. And that's how they wanted this solved for the first part of our problem, in terms of pi. 120 pi square inches. Now, to complete this problem, I have to multiply 120 times 3.14, which is what we're going to use for the approximation of pi. So 120 times 3.14 is going to give us 376.8 square inches. But they wanted me to round to the nearest whole number, which is 377 square inches. For our next problem, they want us to find the surface area of each cylinder to the nearest whole number. Here we're given a cylinder. Our bases, again, we know are circles, and the radius is 3. I know my height, which is the altitude, is 7, and I have a complete net. Again, the circles represent my bases of my cylinder, and the white rectangle is the lateral face. To determine the surface area, I use the lateral area, which is I know is 2 pi r h, plus 2b, which is 2 pi r squared. When I substitute, I'm going to get 2 pi, r is 3, h is 7, plus 2, because I have two bases, pi, and r squared, which pi r squared is the area of a circle, 3 squared. And when I simplify, I'm going to leave this in terms of pi first. 2 times 3 is 6 times 7 is 42 pi, plus 2 times 3 squared, which is 9. 9 times 2 is 18 pi. When I simplify, I'm going to get 42 plus 18, which is going to give me 60 pi. And now I substitute in 3.14 for my approximation for pi. At this point, I have my solution in terms of pi, but they wanted us rounded to the nearest whole number. And when I substitute in, I'm going to get 188.4, but they wanted this rounded to the nearest whole number, which is 188 square centimeters. Again, they want us to find the surface area of this cylinder and round to the nearest whole number. Recall, the surface area is equal to the lateral area, which here, since I'm given a diameter, is going to give me pi times d times h, plus the area of the bases, which is going to be 2 pi r squared. When I substitute, I'm going to get the diameter, which is going to be 8, times the height, which I know is going to be 6.5. Improper fraction is 13 over 2, times pi, plus 2 times pi. And here, my radius is 4 meters, since I know that it is half the diameter. So 4 times 2. When I simplify, 8 divided by 2 is 4, times 13 is 52 pi, plus 2 times pi times 16. 4 squared is 16, gives me 52 pi, plus 2 times 16 is 32 pi. And when I combine like terms, I'm going to get 84 pi. Now, at this point, my solution is in terms of pi, which would be 84 pi square units. Now what I need to do is to multiply that by 3.14. So I substitute 84, 3.14 for my approximation for pi. And when I do, I'm going to get 263.76. When I round to the nearest whole number, that's going to be 264 square meters. On my next problem, they want me to solve this problem in terms of pi. So I know my formula for surface area is equal to my lateral area, which I know is pi times d, since I'm given my diameter, pi times d times h, plus 2 pi r squared. When I substitute, I'm going to have a diameter of 8, a height, which I know is going to be 4 1/4, which is going to give me 17/4 as an improper fraction, times pi, plus 2 times pi times here. Again, my radius is half the diameter, which is 4 millimeters. Therefore, that's going to substitute in a 4 squared. And I have 8 divided by 4, which is 2 times 17, which is 34 pi, plus 4 squared is 16 times 2 is 32 pi. And when I combine like terms, I'm going to have 34 plus 32 is 66 pi. At this point, my solution is in terms of pi, and that is the solution they need me to have it in. So now I just complete 66 pi square millimeters. On this example, I have an oil tank in the shape of a cylinder 76 feet high and a radius of 20 feet, and it needs to be painted. Only one of the bases is going to be painted, as the other base is secured to the ground. Determine the cost of painting the tank if the paint costs $40 a gallon and each gallon covers a surface area of 35 square feet. Here we're given a cylinder, radius of 20, and I have a height of that cylinder, which I know is to be 76 feet. We need to determine the surface area of this cylinder first. I know that a surface area of a cylinder is equal to the lateral area, which I know is going to be 2 pi r h plus 2 pi r squared for the area of the circles. But I don't need the 2, because recall up in the problem that I only have one base that is going to be painted. So I'm going to eliminate this 2. So when I substitute, I'm going to have 2 pi r, I know is 20, times the height, which is 76, plus, remember I'm not going to use 2 because I'm going to use one base, which is one circle, so pi times the radius, which I know is 20 squared. When I simplify, that's going to give me, I get 3,040 pi plus 400 pi. When I combine like terms, I'm going to get 3,440 pi, which is equal to, when I simplify with an approximation of 3.14, 10,801.6 square feet. Now, what I need to do is to determine how many gallons of paint I need to buy. So the number of gallons is equal to the surface area I need to paint, which is 10,801.6, divided by 35, which is the square footage that each gallon will cover. And when I divide, I'm going to get 308.6 gallons. But I cannot buy 0.6 of a gallon. So what I need to do is to round that to the next whole number, which is approximately 309 gallons of paint. Now what I do is I take my 309 gallons and I determine the cost. Cost is going to equal $40 a gallon times the number of gallons, which I know is 309. When I multiply, I get a cost of $12,360. On this example, they want us to determine the surface area of each solid. So here I have a prism and a cylinder. So what we want to do is find the area of the prism and find the area of the cylinder, and then determine what areas are actually going to be missing when they sit on top of each other. So here I have the area of the prism, and we know that equals the lateral area, which I know is the perimeter of the base times the height, plus 2 times the base areas. Therefore, I know that my base is 8 by 3. Therefore, the perimeter is going to be 8 plus 8, which is 16, plus 3 is 19, plus 3 is 22. So the perimeter of the base is 22. The height is going to be 4, plus the base area is going to be 8 by 3, so 2 times 8 by 3, because I have a top and bottom base. And when I simplify, I'm going to get 88 plus 48, which gives me 136 square inches for the prism. When I find the surface area of the cylinder, I'm going to use 2 pi RH plus 2 pi r squared. And here, 2 times pi, r is 2, the height is 3, plus 2 pi r squared, r is 2 squared. And when I simplify, that's going to give me 12 pi plus 8 pi, which gives me 20 pi, 62.8 square inches. But what happens is I have a cylinder sitting on top of this prism. And if I were to paint this, what would happen is the base of the cylinder, the bottom of the cylinder, would not be painted, and also that's covering up the same surface area that is on the prism. So what I need to do is to deduct the surface area or area of the circle, but multiply it times 2 because it's covering up the same area on the prism. So the area of the circle or base of my cylinder is going to equal pi r squared, but I'm going to have 2 circles. So therefore, this is 2 times r is 2 squared. And when I simplify, I'm going to get 8 pi, which is approximately 25.12 square inches. Now, the total surface area is going to be the sum of my prism, which is 136, plus my cylinder, which is 62.8, but deduct the 2 circles that are being covered up, which is 25.12. Then, when I simplify, I'm going to get 173.68 square inches. Again, they want to find the area of the solid. So let's start with the area of this prism. What we have for the surface area of the prism is equal to perimeter of the base times the height plus 2 times the area of the bases. And if I select the base to be 8 by 9, then the perimeter is going to be 9 plus 9 is 18. 8 plus 8 is 16, which when I substitute in for P is going to give me 34. And I have a height of 15 millimeters, plus 2 times the area of the bases, which is going to be 2 times 8 times 9. And when I simplify, that's going to give me 510 plus 144, which is going to give me 654 square millimeters. Now I need to find the surface area of this cylinder. When I find the surface area of a cylinder, that's going to give me pi times d plus 2 pi r squared. And when I substitute, I have pi times d, which I know is 9, and I have 2 times pi, which I know is going to be multiplied by the radius, which I know is half the diameter, which is 4.5 squared. And when I simplify, that's going to give me 9 pi plus 40.5 pi, which equals 28.26 when I substitute in 3.14, and 127.17 when I substitute in 3.14, which is approximately 155.43 square millimeters. Now, that gives me a prism and a cylinder, but I don't have a full cylinder. I have half a cylinder. So what I need to do is to find the surface area of half that cylinder. So I need to divide this by 2. When I divide that by 2, that gives me 77.715. Then I need to realize that this half cylinder is going to be the rectangle, which has the dimensions of 9 by 15. And that covers up the rectangle when I have the cross-section of the cylinder and the rectangle on the base of my prism. So therefore, I need to find the area of that rectangle. Area of rectangle is going to be 9 by 15, but I have 2 of them, which will be, when I substitute in, 270 square millimeters. Now, to find the entire surface area, I just add the area of the prism, which is 654, to the area of half the cylinder, which is 77.715, and deduct out the 2 rectangles that are being covered up, which is 270, and my surface area for the entire solid is 461.715 square millimeters.